Hello guys, welcome to my channel. My name is Varshita. Today in this video we discuss about the Dijkstra's algorithm which is used to solve the problems of single search shortest path. And if you have any weighted graph like this and if you want to find the shortest distance from a vertex to any other vertex in the graph, you are gonna need this method which is Dijkstra's algorithm. So as here we are finding shortest distance, this is known as the minimization problems. So as this is a minimization problem, it is obviously the optimization method. So optimization methods can be solved either by DP, which is dynamic programming, or the greedy approach. So here we are using the greedy approach. So what exactly is the greedy approach? Greedy approach, which means at each step we select the best option. Best option, what is the best option here? Here we will select the least distance at each step. So in the greedy approach, we have a predefined procedure. So here also for Dijkstra's algorithm, we have a simple rule. Before knowing the rule, you need to know some terms, a little terms. If you have a graph like this, A is connected to B is connected to C, and you need to consider that this is a directed graph. Okay. So the first step you need to, this is 30 and this edge cost is 20. Okay. If you have a graph like this, initially first you need to consider the source vertex from where you want to find the shortest distance or shortest path. I take the vertex as A. So I have the source as A. Now we need to find the shortest distance from source A to B and from source A to C also. First, shortest distance, right? Shortest distance from A. Vertex A to A, the shortest distance would be obviously 0. From A to vertex B. So here see, from A to A, the shortest distance is obviously 0. Now, the shortest distance from A to B, as this is directly connected, we take the edge cost as the shortest distance. Remember this. So, as the edge is directly connected, we take the edge cost as shortest distance. So, here you can write as shortest distance d of B is equals to 20. You can denote the shortest distance from A to B is 20 as this. So now shortest distance to C. We don't know shortest distance from A to C because it is not directly connected to A. So we take initially it as infinity. Now our goal is to find the shortest distance to C. For this we have a formula. So if I am finding the if I have an edge like this from X to Y. Now I want to find the shortest distance of Y. We have if distance of X plus cost of the edge from X to Y, if this is less than distance of Y, then distance of Y is equals to distance of X plus cost of the edge from X to Y. So here you need to understand, if I have the edge like this from X to Y, here distance of X is, it is the shortest distance, as like we have a 20 here, distance of B, so distance of X plus this cost of X comma Y, that is edge cost from the vertex X to Y. So here we'll have some weighted value, right? That is the edge cost from vertex X to Y, cost of the edge from vertex X to vertex Y, and then which is less than distance of Y. Distance of Y here, you'll have some value. If this calculation is less than this, then only you need to know that distance of Y is equals to this value, distance of X plus cost from X to Y. I hope this is clear. Let's do here. So here what we have, from B to C, right? From vertex B to C. B shortest distance is 20 and C we don't know, so infinity. What is the edge cost here? 30. Here from here I took as 30. So from this formula or rule, we can say that distance of x, so distance of b plus edge cost from b to c, if this is less than distance of c. Let's see if this actually true or not. Distance of b, what is distance of b? 20 plus cost from b to c, what is the cost from vertex b to c? It is 30. Edge cost less than, what is distance of c? As we don't know, we took it as infinity. So here this is, so is this true? Yes, it is true. 50 less than infinity, yes, it is true. So as this is true, so that's why we are going to the next step, as distance of y, so here y means c, distance of c is equals to 50. I hope you guys understand how we get the distance. So shortest distance from A to B is 20 and A to C is 50. So 20 plus 30, obviously 50. As this is simple graph, we can do like that, or we need to apply the formula. So here I represented everything which I told you now, just now. You can just see for a while. So here you can see the formula, distance of x plus cost of the edge from x to y, if it is less than distance of y, if this is true only, we are gonna change this the distance of y value. If not, if this does not true, then we'll gonna keep the d of y value as the same. So d of y is equals to d of x plus cost of the edge from x to y. Okay, so you can see this is the only formula we are gonna apply in the total problem. So next, let's get into the actual problem.
So this is the graph we are taking. Okay, initially, first of all, we should consider what is the source vertex. Let's take source as v1. Okay, initially we should consider a state. What is the distance from the v1? From v1 to v1, distance is 0, and initially we'll keep every vertex as infinity. Distance from v1 to v2, we don't know the shortest distance, right? So we'll take as infinity. Now we'll take first v1, as v1 is the source node. Okay, from v1, see all the vertices which are directly connected with v. I hope you understand. From v1, which is the vertices which are directly connected to v1. It's v1 to v2 and v1 to v5 and v1 to v3. We don't have from v1 to v4, v1 to v5, which is directly connected. So we'll take v1 to v2, v1 to v3, v1 to v5. These are the nodes which are directly connected with the v1 vertices. Now we'll find the shortest distance. Shortest distance from v1 to v2 and also v1 to v3, v1 to v5. At initially we shall start with the v1 to v2. Okay, v1 to v2. What is the formula? If we have distance of v1 plus cost of v1 to v2, which is less than distance of v2, I take. If this condition is true, then distance of v2 is equals to distance of v1 plus cost of v1 to v2. I hope you understand. Before we took as x to y, distance from x to y, then it will be distance of x plus cost of x comma y. I hope you understand this. Now let's come to here. Distance of v1. What is distance of v1? Distance of v1 0 plus cost of v1 to v2. v1 to v2. What is the cost here? 50, which is less than distance of v2. What is distance of v2? It's infinite. Is this statement true? Yes, it is. So distance of v2 is equals to 50. We update this value now. We'll update this value 50. Is it okay for you? In the same way we'll do for v2 to v1 to v3, v1 to v3 and also v1 to v5. I hope you understand this. So let us do for v1 to v3. What is the formula? Just say with me. What's the formula? Distance of v1 plus cost of v1 comma v3, which is less than distance of v3. If this statement is good, Then distance of v3 is equals to distance of v1 plus cost of v1 comma v3, right? Now let's do this. Distance of v1, what is distance of v1? 0 plus distance of v1 to v3. You should see this edge, not this. This is from v1, this is from v3 to v2, but we need from v1 to v3, so it is obviously 10. Okay, 10, which is less than distance of v3. It's already infinite. I think this statement is good. I mean 10 less than infinity, right? So distance of v3 is equal to 10. We should update this value. Let's update this. It's 10. Now let us do the same for v1 to v5. What is the formula? If distance of v1 plus cost of v1 comma v5, which is less than distance of v5, if it is less than distance of v5, then distance of v5 is equals to distance of v1 plus cost of v1 comma v5, right? Now what is distance of v1? Distance of v1 is 0, obviously. v1 to v5, what is that? 45, which is less than distance of v5, already infinity. So obviously this is true. 45 is a less than infinity. Yes, it is true. So distance of v5 is 45. So let's update this value. It's 45. Am I right? So up to here it's done. So v1 node is already visited node. Now let's keep all these values in the tabular form. This is obviously easy after doing all that. Firstly, initial state, what I told, from v1 to v1 it's infinity, and all other vertices it's infinite. The shortest distance from v1 to all other vertices is infinite, because we did not calculate them yet. So from these all, which is the shortest one, I mean minimum one, it's obviously v1, 0. From v1 we already did v1 to v2 and v1 to v3 and v1 to v5. Let's update these all values in the tabular form. v1 to v2, what is that? 50. v1 to v3, what's that? 10. v1 to v5, it's 45, and remaining vertices all infinite, and we will not write anything in the v1 because it is already visited node. Okay, fine, it is already visited node. v1 is already visited node. Next which vertex we should consider? It is all dependent on the minimum value. What is the minimum value here? v3, right? So let's take here v3 and see which are the directly connected vertices. v3 to v4 we have, right? v3 to v4, v3 to v2, no, we don't have. v2 to v3 we have, so v3 to v2 not possible. So we have only one thing, that is v3 to v4. Okay, let's do this. Do you remember the formula? Distance of v3 plus cost of v3 comma v4, which is less than distance of v4. Then obviously distance of v4 is equals to distance of v3 plus cost of v3 comma v4. If this condition is possible, only you should change the values. Okay, now distance of v3, what is distance of v3? We have distance of v3, it is 10. What is cost of v3 to v4? It's 15, less than distance of v4, obviously infinity, and this is 25 is less than infinity, which we, if this condition is already it's true, so distance of v4 is equals to 25. Let us update this. Distance of v4 is 25. Here also from v3 to v4 now 25, and remaining will be the same, 50, 45, infinity, and we will not write this because the v3 node is already visited, right? In the same way as before, let's consider the shortest one. Which is the shortest one in these all? I mean minimum value, it's obviously 25, which is v4. So let's write it here, v4. From v4 what are the possibilities? v4 to v6, obviously we have v4 to v6, yes. v4 to v5, yes. v4 to v2, yes. We will not consider this v1 and v3. because these vertices are already visited. So let's take v4 to v6 and v4 to v2 and v4 to v5. We shall calculate now all the shortest path, all the distances. Now firstly v4 to v5. Okay, again tell me the formula. Distance of v4 plus cost of v4 comma v5, which is less than distance of v5. If this is good, then if this is true, then distance of v5 is equals to distance of v4 plus cost of v4 comma v5. True. So now distance of v4. What is distance of v4? Distance of v4 25 plus cost of v4 to v4 to v5 I'm asking, which is 35. As this graph is a directed graph, we have all this. If it is undirected graph, there is no problem, which is less than distance of v5. Distance of v5, what is distance of v5? 45. See here, how much is this? 60 less than 45, which is false, so we'll not update the value of distance of v5. Okay, I hope you understood here. 60 is less than 45, which is not possible, which is false. So distance of v5 will not be updated anymore. It will be 45 only. Okay, next one we'll write as v4 to v2. Okay, tell me the formula. Distance of v4 plus cost from v4 to v2, which is less than distance of v2. If this is true, then distance of v2 is equals to distance of v4 plus cost from v4 to v2, if and only if this statement is true. What is distance of v4? Distance of v4 is 25 plus cost from v4 to v2, which is 20, which is less than distance of v2, 50. So is this true? 45 is less than 50. Yes, it's true. So distance of v2 is equals to 25 plus 20, which is 45. So update the value. 45, right? So we calculated distance v4 to v5 and v4 to v2, and the remaining is v4 to v6. v4 to v6, right? Tell me the formula. If distance of v4 plus cost of v4 comma v6, which is less than distance of v6, if this is true, then distance of v6 is equals to distance of v4 plus cost of v4 comma v6. Am I correct? Yeah, let's write it down. Distance of v4. What is distance of v4? That's 25 plus cost of v4 to v6, it's 3, which is less than distance of v6, and find it. Obviously it is true. So distance of v6 is 28. 23 plus 3, it's the 28. So 28. Update these values in the tabular form. We'll update this. From v4, what we have? From v4 we have before. What are the possibilities? v4 to v6, v4 to v5, and v4 to v2. From v4 to v6, what is the updated value? v4 to v6, it's 28, right? Next, v4 to v5, what is the updated value? It is the same, 45. From v4 to v2, what is the updated value? It's 45, and the remaining are same. It's obviously the same. And v4 we do not write because it is already visited node. From here, which is the minimum value? Minimum value is 28, which is v6. From v6 we do not have any connected node, any directly connected nodes. So we'll write the same, 45. From these, both are same, so we can take anything, v2 and 45. So v5. So this is the final table. We'll get rise This is the final table we'll get. So as in starting, how I told, we can find the shortest path or shortest distance, right? So from here, how can you find? I'll tell you. If they are asking the shortest path, let us consider from V1 to V6. What is the shortest distance they are asking? Shortest distance. If they ask about the shortest distance from V1 to V6, V1 is this, right? V6 is this, right? The last value is 28. So 28 is the shortest distance from V1 to V6. Okay. Next V1 to V5. Let's take V1 to V5. What is the shortest distance? V1 and V5. Which is shortest distance? 45 is the shortest distance. V1 to V5, which is 45. Suppose V1 to V2. V1 to V2. Obviously it's 50, but the shortest path is V1 to V2 is 45. We can reach in 45. So like this you can consider. Suppose V1 to V1, what is the shortest distance? 0. V1 to V2, what is the shortest distance? 45. V1 from V1 to V1, what is the shortest distance? Is 45. V1 to V2, what is the shortest distance? Is 45. From V1 to V3, what is the shortest distance? 10. V1 to V4, 25. V1 to V5, 45. V1 to V6, it's 28. So this is all about shortest distance. Now coming to shortest path. So let me tell you here, let's take a as like a pointer or something symbol which points to that particular value. If they are asking about the shortest path from V1 to V2, see, V1, V2, this is the path, right? V2. Here we'll take a pointer. Okay. Then just move up if it is the same value, and if it is the different value, search for the minimum value in that particular row. So let's move up. Is it the same value as like before? Yes, 45, right? Again move up. Is it the same value? No. Is it the same value? No. So search for the minimum value in this row. What is the minimum value? It's V4, right? So we'll write here V4 and again move up. Is it the same value as before? No. Again search for the smallest element. It's V3. Again move up. Is it the same? No. Search for the minimum element. It's V1. So write it there. So this is the shortest path. V1 to V3, V3 to V4, V4 to V2. And what should be the value? The shortest distance from V1 to V2 is 45, right? So this should be the value. Search and you'll get this. V1 to V3, what is that? 10 plus V3 to V4, it's 15 plus V4 to V5, it's 20. How much the total? 20, 30, 45. Is this 2 equal? So it's true. I hope you understand this problem. If you understand, please like, share and subscribe. Thank you.